Hello! In today's lesson we are looking at trigonometric ratios. Our objectives are to find the sine, the cosine, and the tangent of an acute angle, and to use trigonometric ratios to solve real-life problems. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. Sine. A sine is a trigonometric ratio abbreviated as sin, except we don't call it sin, we say sine, but we write it as sin, sin. Cosine. Cosine is a trigonometric ratio abbreviated as cos. Again, we don't say cos, we say cosine, even though we spell it as cos. That is the shortened form of cosine. Tangent. A tangent is a trigonometric ratio abbreviated as tan, we say tangent. Angle of elevation. An angle of elevation is the angle that your line of sight makes with a horizontal line when you stand and look up at a point in the distance. Here's the trigonometric ratios. Let triangle ABC be a right triangle. The sine, the cosine, and the tangent of acute angle A are defined as follows. So we are going to be defining our sine, cosine, and tangent with reference to angle A. So over here. Sine of angle A is our opposite side, which is right across from angle A, over our hypotenuse. And for writing the trigonometric ratios, that would be A over C. Cosine of angle A is our adjacent side, which is the one that's right next to angle A but is not our hypotenuse. So it's our adjacent side over our hypotenuse, and that's B over C. Tangent A is the side opposite angle A, so that's across from angle A, over our adjacent side, the side that's next to angle A that is not our hypotenuse. So the side ratio is A over B. Here's a quick way to remember the trig ratios. A common method that teachers often show their students how to remember the trig ratios is they would say SOHCAHTOA, where sine is the opposite over the hypotenuse and cosine is the adjacent over the hypotenuse, and finally tangent is opposite over adjacent. Another interesting way to remember the trig ratio is to remember this phrase: some old hippie caught another hippie tripping on apples. Example 1, finding trigonometric ratios. Find the sine, the cosine, and the tangent of angle P. Angle P is right over here. The length of our hypotenuse is the side that is across from our right angle, which is 17. The length of the side opposite of angle P is 15. And the length of the side adjacent to angle P, that is the side that's right next to angle P, which is not our hypotenuse, is 8. To find sine A, we know that it is the opposite over the hypotenuse. Opposite length is 15, hypotenuse is 17. Plug that into your calculator. 15 divided by 17 is approximately 0.8824. Cosine of P is your adjacent over your hypotenuse, which is 8 over 17. Plug 8 over 17 into your calculator, you get 0.4706. And then tangent of P is your opposite over your adjacent, which is 15 over 8, which plugged into your calculator, you get 1.875. Trigonometric ratios for 60 degrees. Find the sine, the cosine, and the tangent of 60 degrees. Begin by sketching a 30 degree, 60 degree, 90 degree triangle as shown on the right. To make the calculation simple, choose 1 as the length of your shorter leg. From the 30 degree, 60 degree, 90 degree triangle theorem, it follows that the length of the longer leg is square root of 3 and the length of the hypotenuse is 2. Label these lengths in the diagram. So sine 60 degrees is opposite over hypotenuse, which the opposite of angle 60 is square root of 3, hypotenuse is 2, so plug square root of 3 divided by 2 into your calculator and you get 0.8660. The cosine of 60 is your adjacent over your hypotenuse. The adjacent side is the side that is next to 60 but not the hypotenuse, so that is 1 over your hypotenuse, which is 2. Plug that into your calculator, you get 0.5. Tangent of 60 degrees is your opposite over your adjacent. Opposite is square root of 3. Adjacent is 1. Square root of 3 divided by 1 is just square root of 3. Plug that into your calculator, you get 1.7321. Example number 3, indirect measurement. You are measuring the height of a flagpole. You stand 19 feet from the base of the pole. You measure the angle of elevation from a point on the ground to the top of the pole to be 64 degrees. Estimate the height of the pole. I'm going to draw a picture of me over here standing. This is my horizon over here, and then I'm looking up at the flagpole to get that 64 degrees. And I need to find my height in this question. So I'm looking at the 64 degrees and I'm saying, okay, well, in relationship to this 64 degrees, that is my opposite. And in relationship to this 64 degrees, this 19 feet is my adjacent. So I know that I am going to use the tangent function over here because tangent is opposite over adjacent. So I can write tangent of 64 degrees is equal to the opposite over adjacent, where 64 degrees represents my angle measure. I know that the tangent of 64 degrees is going to be opposite, which is my unknown, that's the height, over 19. Cross multiply to isolate h, so we get 19 times tangent 64. Tangent of 64 is approximately 2.0503. Multiply that by 19 to get the height as approximately 38.9557. The height of our flagpole is approximately 39 feet. Alright, checkpoint problems number 1, 2, and 3 are yours. For each of these problems, you are to use this triangle over here to find the trigonometric ratio. I want to find out what sine x is, cosine x is, and tangent x. Alright, that's it from me. I'll see you all soon.